We previously learned that power is just a measure of the work done in a certain amount of time, or we can look at the equation P is equal to work divided by time. And we calculated power by looking at how many joules of work were exerted within a certain time frame where the time was always measured in seconds. However, when it comes to electric power, rather than measure the joules exerted, it's actually a lot easier to measure those properties of electricity, current, and voltage. And it turns out if you measure those, there's a very simple relationship that allows you to calculate the power. Electric power, is simply given by the voltage times the current. And the unit ends up being in watts, just like we expected before. So a really simple example, you have a brand new 1.5 volt D-cell battery. So we say, okay, volt. That means my voltage is 1.5 volt. And it can deliver 13 amps through a copper wire. So amp is a measure of current. So my current is 13 amps. So we need to be able to recognize our units and what they're measuring. Determine the power of a brand new D-cell. So my question here is my power is equal to what? So we have voltage and current, and we need power. So obviously we're going to use that equation we just learned. Power is equal to voltage times current. My voltage here is 1.5 amps times my current. I'm sorry. What am I doing? 1.5 volts, that's my voltage, times 13 amps, that's my current. So voltage times current. And I do the math on that, and I get 19.5, and it gives me the units of watts. So my power here is going to be 13.5 watts. Super simple. So if it's talking about electrical systems, such as having a battery or a circuit or something like that, gives you a voltage and a current. Sometimes it doesn't say current, but it gives you the units that let you know it's current. You can really easily calculate power using this new relationship, power equals voltage times current.